Hello friends, welcome to my channel. So let's have a look at problem 59 together, the spiral matrix 2. So we saw that there are 4 such problems in Leetcode. So we're going to share the solutions for all these 4 problems using the rotation matrix method. Here, let's look at this problem, spiral matrix 2. First, we'll quickly read through the statement of the problem, and then we are going to share the idea and analyze the method, and then we are going to share the code and do the tests. So first, let's look at the statement. So given a positive integer m, so we are required to generate an n by n matrix filled with elements from 1 to n squared. So in total, these are n squared numbers, so in spiral order. So here is the specification. For example, we can first along the top walk to the right, then downwards, then to the left, then to up, and then to the right. So finally we get this none. So this is example 1. So example 2 is sort of trivial. So here the constraint is about the size of the matrix, or the total numbers. The n is less or equal than 20, so it's actually a small number. So actually for this problem, so if we follow the method in the video for Leetcode 26, so this is sort of straightforward. So here we'll do it in a much quicker fashion. So the method we're going to use is the rotation matrix method. So here the key is how to detect direction change, and how to update direction. Right. So similarly for the first question, so we meet the boundaries or meet something which already set. For example, when we look at 8, if we continue up, so we're going to meet 1. 1 is already set, so we are going to change direction. So how to update direction is exactly what the rotation matrix does. So in general, the rotation matrix is given by here. So it's cosine theta. Let's call cosine A just for convenience. Cosine A, cosine negative sine A, and sine A, cosine A. So here A is the angle, and the angle in a angle in counterclockwise fashion. So if we want to rotate the direction in a clockwise fashion, so the degree is negative. So here the degree is actually for A is 90 degree, but it's negative. So if you compute, the rotation matrix is nothing but, so cosine 90 is 0, and negative sine negative 90 is 1. So and sine negative 90 is negative 9, and here is 0. So that's the rotation matrix. So if we have a direction, say it's called dr, dc. So originally it's you can set it as 0, 1 because it walks to the right. Then basically let's call this vector. Let's call its vector is dr and dc. Then we're going to use matrix on multiplication, so r times v. So we're going to get the update rule. So if you compute, what we get is that this will be this row times this column. So this will be dc. So the second one will be negative dr. So that's the direction update rule. So for details and how we get this rotation matrix and how to compute this matrix, and you can refer to this 23, 26 for further details. So with that said, we grasp the idea for the two key questions. Now we are in a position to write the short code. So in this problem, we're going to return the matrix. So we're going to first set the result as the following. So 0 times n for a dummy index in range n. So here we notice that n is the number range is from 1 to n squared. So we set it at 0 for the convenience of check in the later. So if the position is not 0, it means it's already set. So with that said, let's specify RC equals 0, 0. So this is the start position. So dr dc, that's to be 0, 1. So this is the start direction. So we are going to use a number called current to mimic the process. Then this also provides the stop condition. So while current is less or equal than n squared, because we want to set n squared numbers. Then once this condition holds, so we are going to set the result for the current index RC equals current. Once we reset, we're going to increment the current by 1. And next, we're trying to update this R to R plus dr and C to C plus dc. However, we need to check if we need to change the direction using the rotation matrix. So for that, let's do the check. If R plus dr is less than 0 or R plus dr is greater or equal than n. So this are auto bound condition for the row index. Similarly for column, C plus dc is less than 0 or C plus dc is greater or equal than n. So or in other case, so in other case is that the number is already set. So in other words, the result R plus dr C plus dc is not 0. So if this is the case, we are going to update the direction. So from the previous direction dr dc, so we can update it to dc negative dr. So it's dr dc is updated to dc negative dr. So with that done, what we want to do is that we update the position for traverse. So r plus dr, c plus dc. So that's about it for this solution. So now let's return the result. So first I'll do a special case check for example 1. Let's see. Yeah, it passes this example. Let's do another one. Let's see 5. Yeah, it passes this one. So now let's do a generic case check. It passes all the generic case. So this is a total solution for this problem. Again, we are following the previous two videos using the rotation matrix. It's very straightforward in some sense. So now here we want to ask a question. So the question is, can we do the traverse here to the traversal here in a counter clockwise fashion, right? So that's actually sort of straightforward. Let's copy this code, and then we're going to reset this one as method v1. So here I'm going to write one using counterclockwise fashion. So for this, basically the rotation matrix is changed. So here we have A is negative 90. So but for counterclockwise, the A is positive 90. So let me write here for counterclockwise. The rotation matrix, so R equals, so cosine 90 is 0 and positive 90, so it's negative 1. negative sine A, negative sine 90 degrees, negative 1, and sine A is 1, and cosine A is 0 still. Then we do the matrix multiplication, so R times V, it equals, so this 0, 1, negative 1 times this column, so we get negative DC. Negative DC, and also this this row times this column will get dr, right? It's corresponding to take the first element in this V vector. So this is the update rule for the direction. So here basically we do not need to change anything. We change the stock direction to be negative 1. So we move to the left, and then the direction update rule is negative DC dr. So it's negative DC and dr. Then if we do the check, so this is a counterclockwise traversal. So you can test for the case 3 to make a comparison with the example 1 here, right? So also another thing is that is this direction. Actually, you can change the direction to be so here I'm changing to the leftwards. You can change to the downwards. So in other words, dr is 1 and dc is 0. It actually does the same thing. So here is 1, 2, 3, 8, 9, 4. Remember this and try it again. So we get the same thing, right? So this is a counterclockwise fashion. So the solution to this problem here is clockwise traversal. So with that said, actually we solved this problem, and also we extended to do a traversal in a counterclockwise spiral fashion. I guess that's all about it. Thank you very much.